Hello. So now I will be solving question number 2 from phase 1 book, Forces and the Laws of Motion chapter. So let's read the question. A block is kept on the floor of an elevator. This is the diagram. So there is an elevator which is going downward with the acceleration 12 meter per second square. The elevator starts descending with an acceleration 12 meter per second square. Find the displacement of the block. We have to calculate the displacement of this block during the first 0.2 seconds after the start. So after the start, what will be the displacement of this block we have to calculate. Okay. Now, this is a patient which is based upon the pseudo force concept. If you see this patient, this system is going downward with an acceleration 12 meter per second square, which is more than g, which is 10 meter per second square. So in this case, we will see that the contact between this block and the lift will be lost. To check that, let's solve this question first with respect to elevator. So what I'll do, I'll fix my observer onto the elevator. So with respect to elevator, I'll make the FBD of the block. I'm going to make the FBD of this block with respect to the elevator. Okay. So how many forces? So if you see FBD of block with respect to elevator, and as I keep teaching in the class, when we show the forces, first field forces and then contact forces. So first I'll show the field force and then I'll show the contact forces. What are the field forces? mg, which is the field force. mg always acts downward. Apart from the mg, the pseudo force is also a field force, and the direction of pseudo force will be opposite to direction of acceleration. So acceleration is downward, so pseudo force will be in the upward direction. Let's call it FSH, and the value of this is m into a. Apart from that, there are two field forces. There is no other field forces there. Now we'll see the contact forces. Now, how do we see the contact forces? Contact force depends upon number of contacts. So there can be only one contact. There is only one contact. So contact force will be only acting at this point. And that contact force will be known as a normal. So the floor will apply the normal onto the block. And as far as the normal is concerned, direction of normal is perpendicular to the surface, away from the surface, which in this case will be coming in upward direction. Since I'm looking at the block with respect to lift, I'm looking at the block with respect to lift, and I'm assuming no relative motion. Why I'm assuming no relative motion? Because I'm assuming these two things are in contact. I'm assuming normal reaction is there. Since normal reaction is there, block and the floor has to be in contact. If block and the floor is in contact, in that case, block will not move with respect to floor. Based upon that, acceleration 0. So this is the acceleration with respect to the lift. So we'll balance the force. mg is acting downward. So mg is m into 10 minus FSH, which is m into 12 minus n is 0. N will come out to be 2 times of m, minus 2 times of m. Not possible. Normal reaction will always be in upward direction. In this case, it cannot be downward. Since negative force is coming, and what we do in case of negative value, we change direction, which in case of normal is not possible. In case of normal, it cannot be in the downward direction, so this is not possible. Normal cannot be minus 2. If I'm getting the value of normal reaction as minus 2, which is not possible, it means something I had assumed is wrong. And what I have assumed? I assume the non-zero value of normal. So normal cannot be negative, it will become 0. The moment normal reaction in this case becomes 0, it means this body and the floor loses contact. The moment body and the floor loses contact, there is no normal reaction. So now, with respect to ground, let's go with respect to ground now. Now, if I go with respect to ground and make the FBD of the block, I'm making the FBD of the block only. Now, ground is an inertial frame. First field forces will show. Field force will be mg. So weight does not depend upon where you are looking at it. But since right now I'm sitting onto the ground, which is an inertial frame, I don't need to apply the pseudo force. No pseudo force. And apart from that, there's no contact. Here itself, I know Here I'm knowing that normal reaction is 0, so there is no contact. If there is no contact, there is no contact force. So in this particular case, there is only one force, that is mg, with respect to ground, and the acceleration will be in the downward direction, which is a. So you will calculate, and the a will come out to be g. Meaning the lift is coming down with the acceleration 12 meter per second square. And this block is coming down with an acceleration of 10 meter per second square. Block is moving slower than the lift. So with respect to lift, when you will see the block will go up. But with respect to ground, block is falling freely with acceleration g. Now I know the block starts from rest according to question. Lift starts from rest, so block starts from rest. And the acceleration of block is g. And they're asking the displacement of the block in first 0.2 seconds. So I'll use the formula. Displacement is equals to ut plus r a t square. So we need to calculate displacement. Initial velocity is 0. 1 by 2. Acceleration is g, and 0.2 square. So 1 by 2 to 10 to 0.04, and finally you will get the value of 20 centimeter. So displacement of this block with respect to ground is 20 centimeter. Now this is a very good question, because the thing is, in this case, the contact lost. We were assuming that contact might not lose. Contact loss because we were bringing this lift downward with the more acceleration than the g. Okay. And the second thing, if you see this equation, nowhere they have defined with respect to what you have to calculate the displacement. Some of the students, when they will attempt this equation, they will calculate the displacement with respect to lift, and they will be wrong. Please remember, whenever examiner is not defining the frame, it's always inertial. It's always inertial. If in the question they are asking with respect to lift, then you will calculate with respect to lift. If they are not defining it, it's always with respect to ground. You have to calculate the kinematical quantity. Understood? So this is a very nice question where a lot of physics was involved, less mathematics, more physics was involved. I hope you understood it. And this is the application of pseudo force as well. Okay. I hope you understood, and any issue, please let me know. Okay. Thank you.